Welcome to this puzzle session. Here is the problem. A line is colored with two colors. So just imagine a line and every point of it has been assigned a color, either red or blue, let's say. We want to show that one can always find a segment of non-zero length, something like that, whose endpoints and the midpoint all receive the same color. So no matter how you choose to color a line with two colors, you will always find 3 points which are of the same color and such that the 3 points are arranged in a special way, meaning the one in the middle is actually the midpoint of the extreme ones. So I hope the problem statement is clear. And as usual, you're encouraged to pause the video before we look at what I'm going to discuss. And with that, now let us move on. So here is a line and every point has been assigned a color, red or blue. Now, since there are infinitely many points and only two colors being used, some color must repeat at least once. That's a massive understatement, but that will do. So let's say the color red repeats and we have 2 points. One is here and one is, let's say, here. It's not really centered. I want to put it in center. So maybe one is here and the other is, no, this is the same. Anyway, it doesn't matter. So some color must repeat, and we have, without loss of generality, assumed that color red repeats, and we have drawn 2 points which have the color red. Now this is the midpoint of these 2 points, and if this is also red, then we have the line segment of our choice, the line segment that we wanted. So the adverse case is that this is blue colored, and we may color it blue. Okay. Now this is some distance, call it D. Okay, now choose a point which is at a distance 2D from here. Now, what about this point? If this point is red, then these 3 points together form the correct line segment, meaning this is the midpoint and all of the 3 of these will have the same color. So we may assume that this also has color blue in the adverse case because otherwise we are done. So this has blue color. And similarly, on the left side, by the same argument, this must also be blue, or rather I should say that in the adverse case, we may assume that this is blue. But now, if you look at it, these 3 points are all blue, and this one is the midpoint of the extreme ones. So inevitably, we will find a segment as desired, as demanded by the problem. So that finishes the proof. And with that, I want to end this. As usual, like, comment, share, subscribe, and I will see you next time. All right.